In the US alone, there are over 250 million cars on the road. If you do the math, that's over 1 billion tires. Millions of those end up in a tire mountain like this one.
I'm Nick Meister here at Hudson, Colorado, the biggest tire dump in the world. You know, most people look at this place and they just see a big pile of waste. We look at things a little bit differently. We see a problem that's begging for a solution, and we see an opportunity.
When I see a pile of tires, I think, what a tragic waste of an extremely valuable material.
Every community is challenged by getting rid of tires. Rubber is one of the least recycled materials in the United States.
Rubber is a fascinating material. The world can't exist without rubber. You can imagine a loaded 747 coming out of a minus 65 degree sky and landing on tires on 120 degree tarmac. Nothing but rubber in the world can survive that. But those very properties of rubber that make it so resilient to punishment are also the part of the problem in recycling it.
The core of the problem is vulcanization. It's the same process that gives rubber its incredible capabilities and makes it one of the world's most important resources. It also makes rubber a single-use product.
The combination of pressure and temperature and the inclusion of sulfur gives rubber its stability. That made rubber really a useful material.
Once a tire is vulcanized, this is like an epoxy compound or cement. Once it's set into a fused state, you can't easily break the bonds, and this has been the challenge. The history of recycling rubber has always been shredding and grinding and creating particles or powder. We're only using a very small percentage of rubber. Scrap tire rubber has gone into playgrounds, mulches, gardening supplies of all kinds, rubber in the roads with asphalt. I've seen a dozen companies come and go, and they all do the same thing. They grind, they shred. That is not really an answer.
Tires are burned in cement kilns, which is a tragic waste of a very valuable resource.
Until now, naturally harvested rubber could only be vulcanized once. What if someone came up with a process to return vulcanized rubber to its virginal form, give it a second life?
It's a very unique way how we go about refusing the rubber.
We can achieve 85 to 95% of the properties of virgin compound.
We're here in Bay City, Texas, just a few miles from the Gulf of Mexico, at this beautiful state-of-the-art plant. And you know, the only thing that's got me more excited about the economics behind this proposition is the environmental impact.
The industry at large has not scientifically focused on rebonding mechanisms. That's where we are focused today, revulcanization.
It's a chemical type process that takes the rubber that's been vulcanized and devulcanizes it.
Very precisely severs the sulfur bonds to the rubber molecule, but does not sever the bonds within the rubber molecule.
Devulcanization would create a feedstock out of waste, basically. So it would reduce the amount of natural resources that we're consuming, but more importantly, it would get rid of a huge waste stream.
We have an abundant supply in US, Canada, and Mexico of waste rubber, so we will never run out of rubber, and we'll always need rubber.
We can take all of that waste that we have been storing for years, and that can be our salvation in the future when commodities are scarce around the world. What we have here is crumb rubber, which is essentially just a ground up tire. You cannot stick this together. Even if I put it in that press over there, it will not stick together. And I'm going to dump this material into this mixer. One of the advantages of the technology is that it's relatively low temperature. If you get really high temperature, that affects the properties of rubber. By being relatively low temperature, we preserve the properties of our material. And then I will add 2 chemical compounds. These are proprietary specialized compounds. They're the secret recipes that achieves the selective shearing of the sulfur to hydrocarbon bond. And we're ready to start the devulcanization process. We have 3 specialty compounds. This material, which is called activator, this clear liquid in here is called catalyst, and this is the modifier. The modifier stabilizes the sulfur in the compound. I'm going to open this valve, and I'm going to put these materials into the mixer now that I have the rubber up to 176 degrees. So that's the activator. And now I'm going to add the catalyst. The chemical reaction of devulcanization is now happening in the mixer. It takes 2 minutes. Now I'm putting this in there, the modifier. I have to open this gate valve, and now we start a 3-minute process.
So you notice there is no off-gassing.
Right, and it's not like you have a big stack of smoke coming up and gathering in here.
I'm going to start the cooler. It has absolutely no carcinogens. It has no emissions that require regulation of any kind.
We could be in a residential neighborhood. There's no fumes.
We'll simply open the valve down here.
Nice. This is beautiful. Yeah.
And you can almost see it looks almost alive. It almost looks like it's moving. Even a very inexperienced layman can see easily that there's a change in the material. We can take this material as it is, and for many products, they can simply put a curing package in and take this devulcanized rubber and make a product. This is a lab mill. It's a small mill. I'm going to demonstrate what happens with ordinary crumb rubber. No matter how many times I put this through, it'll still be a powder, but it doesn't bond. Now if I take our devulc material, you can see on the first pass already how it's sheeting up. If we wanted to sheet the material, and we would run it right out of the cooler directly into a sheeting mill. This is now a devulcanized master batch ready for a customer in slab form or in powder form. Like we're going to make a sample sheet of rubber, vulcanized rubber. So I have to mix a curing package into this. Now we're going to cut a piece of this and put it into that press to make a vulcanized rubber product. This is a 50-ton press. So this is the vulcanized rubber sheet produced from our batch that we just did.
What are you looking for when you're seeing if the quality?
I'm looking for good dimensional, cross section. You can see that we have pretty good tolerance here. We're looking for fold, crease, fracture. We're looking for elasticity, elongation, which in this case is like 400% or 500%. If you hold this up to the light, the question is, do you see any permeation or pinholes? And so far, nothing. It's very dense. We've achieved very positive results of an excellent product here that really is quite marketable.
We have a massive market, the devulcanization of rubber and supplying a new material back into industry.
We've got to go this devulcanization route and put it back into rubber products.
Re-enter the rubber back into mainstream, the new rubber goods, vulcanized rubber goods.
There is a shortage of raw materials globally. They can't keep up with the demand. We've got a global market that we can approach and sell our product to. We can process it, ship it overseas, and still be profitable in doing it.
Large amounts of material will be sold to the tire companies and to other manufacturers.
The avenues where you can put this material is never ending.
After 15 years of wrapping my life around this, I cannot conceive of a situation where we can't sell everything we can produce. This plant was originally permitted in 74 days because there's no emissions. We put nothing into the air, nothing into the land. When you can take our nastiest waste in the world, create good solid economic value out of it, and put no pollution back into the world, I get really excited about it. That's fun.
Our mission is complete recycling, to use 100% of our feedstock, tires, in a process which recycles the world's rubber and captures its full potential.
The promise of devulcanization is that you can get a clean feedstock that can be used basically with the same flexibility as the original product.
We're regenerating rubber into new markets, bringing rubber back to the road.
In a way, we're lucky that we wasted so much because now we can recover it all economically, and that can be a supply of raw materials for society for many, many, many years.
It will be transformative.
Well, it works. It's obvious, and our experts agree. And I'm so excited for the next step, to get this plant fully operational, and others like it, all around the world. I drive down the highway here in Texas, and all the trucks and the traffic, and you look at all those tires, and it feels good. I'm passionate about it. I feel that it is a significant change in society that we can achieve with this technology.
Our business is environmental technologies with economic viability, possessing the only technology on Earth that brings waste tires back to life gives us the rare combination of a massive environmental impact, which may only be surpassed by the economic windfall. When most people start businesses, the first thing that comes to mind is profit. Now, of course, I'm excited about that, but the chance to change the world for the better, that's what's really got me fired up.